So here's another section 2.3 that, students generally don't have problems with. So I'm going to kind of just briefly remind you some facts about lines. So let's suppose I have a line in the plane, and I pick 2 points on the line, x1, y1, and the other one is x2, y2. If you calculate y1 minus, or y2 minus y1 over x2 minus x1, it turns out that that number is constant along the line. It's independent of which actual 2 points you pick along the line. It's because of similar triangles. If I picked these 2 points, then that change in y over change in x is the vertical and horizontal distance I see in that right triangle. What if instead, say, I picked these 2 points? Why would this vertical over horizontal be the same as the vertical over horizontal in the big triangle? It's because those two triangles are similar. How do I know they're similar? Well, they've got this angle in common and one other angle in common. Do you see it? Yeah, the right angle. If two triangles have two angles that are the same, they must have all three that are the same. And that means they're similar triangles. Similar triangles means corresponding sides are in ratio. So the ratio of vertical to horizontal on the big triangle is the same as vertical to horizontal on the little triangle. So no matter what 2 points I pick along the line, as long as I calculate this thing, I'll get the same number along the line. So it's said to be constant along that line. It's called the slope. Well, what does slope tell you? Well, slope tells you the change in y. I use that capital Greek delta to stand for change. The change in y when x changes by 1 unit. If you move 1 unit to the right, slope tells you how much the curve is going up or how much the line goes up or down. So when the slope is positive, that means the line is moving up as I move to the right. So along all of those lines, the slope is positive. When the slope is negative, it's because y goes down when x increases by 1 unit. Maybe a lot, maybe a little. But in these lines, the slope is negative. If the slope is 0, that means y doesn't change at all when x increases by 1 unit. The line is horizontal. And vertical lines have no slope, because if I pick any 2 points on a vertical line, there's a change in y, but the change in x is 0, and I can't divide by 0. So the slope does not exist on vertical lines. And the slope is 0 on horizontal lines. Let's talk for a minute about finding equations of lines given some data in a problem. I say equations of lines because every line has lots and lots of different equations. You could do a little algebraic fiddling with the equation to get a different equation for the same line. So one form in which I see equation of lines really frequently in students' homework is what's called the slope-intercept form. If my line occurs to me, if its equation is given like this, y equals some number times x plus another number, then that multiplier of x has to be the slope. And that number has to be the y-intercept. Because see, if x equals 0, y equals b. Okay, that's useful if somebody says, I'm thinking of a line whose slope is 7 and whose y-intercept is 14, I could find the equation that way. For most other problems, though, it's not terribly useful. It's also, the one way that slope-intercept is useful is if somebody gives me the equation of a line, and I see that it looks like it's slope-intercept form, see that it's in slope-intercept form, then I can read off the slope of the line without doing any more calculations. But what's far more useful for finding equations of lines in problems is what's called point-slope form. If someone tells me that a line has slope m, some number m, and passes through some point whose x and y coordinates are x naught and y naught, then y minus y naught equals m times x minus x naught has to be an equation of a line. Really, really useful. Then there's this last form that shows up, it's mentioned in the book. I can't think of why you would really need it, but I'll just mention it just to be complete. The general form. Any line can be written as something times x plus something times y equals something else. You know, ax plus by equals c. There's really no geometric interpretation to a, b, or c. I think the slope has to be negative a over b, and c over b is the y-intercept, and c over a is the x-intercept. It's kind of a stretch to say that that's terribly useful for anything. But let's try a problem. Let's suppose, well, I won't say find the equation, I'll say find an equation of the line. How about goes through the point 1, 7 and the point negative 2, 5. Well, given 2 points, I could find the slope. So the slope is change in y over change in x. I know in the formula that I showed you before that delta y was y2 minus y1 over, and delta x was x2 minus x1. But it really doesn't matter which one of these we call x1 and y1 and which one we call x2 and y2. For instance, I could say that the numerator is 7 minus 5 as long as I say that the denominator is 1 minus negative 2. Or I could say that the numerator is 5 minus 7 as long as I say that the numerator is negative 2 minus 1. As long as I'm consistent about subtracting this in the numerator and that in the denominator, I'll get the correct slope. So that's negative 2 over negative 3. The slope is 2/3. So it's easy to find an equation of the line. Let's use point slope. The line that goes through, say, 1, 7 with this slope must be y minus 7 is 2/3 times x minus 1. Or if somebody said, well, the equation must be y minus 5 equals 2/3 times x minus a negative 2, you'd also be correct. There's lots and lots of ways to find an equation of the line. I've seen students, stick in x equals 0 so they can learn what the y-intercept is so they can write the form in the line and slope-intercept form. I think you did this because you had some high school teacher in your past who insisted that you write lines in slope-intercept form. There really is no practical reason to insist that somebody do that, unless you want to just make grading the math exam a little easier. Let's try another. How about, let's find an equation of the line that goes through the point about 1, 5, and 3, 5. Okay, so I calculate slope. It's going to be 5 minus 5 over 3 minus 1. That's 0 over 2, that's 0. So I think it looks really simple. It looks like y minus, I'll use point slope form again. How about I'll use this point? Y minus 5 is 0 times x minus 1. But that's really simple. 0 times x minus 1 is just 0. The equation is y minus 5 equals 0, or y equals 5. That answer makes sense because along a horizontal line, the x is changing, but the altitude of the line isn't changing. Y is a constant. Horizontal lines always have equations that look like y equals some constant, y equals a number, a really simple equation. Vertical lines have really simple equations too. Vertical lines all have equations of the form x equals a constant because along a vertical line, y is changing, but the horizontal position of the point on the line isn't changing, so x equals some constant. So here's some facts that are useful about lines. Except for vertical lines, which don't have slope. Slope has a lot to do with, tells us everything about parallelism and perpendicularity. Parallel lines have the same slope. If this line has slope m1 and this one has m2, then m1 has to equal m2. And perpendicular lines have slopes, well, that satisfy this. m1 is the negative reciprocal of the other. If that has slope m1 and this has slope m2, then m1 is negative 1 over m2. Or the shorter way to say that, but it seems to really puzzle students when I do, it's that m1 times m2 has to equal negative 1. So let's try one more find the line example. I guess I'm on example 3 here. Let's say find the line perpendicular to this one. Y minus 4 equals 3 minus 5x. And passing through the point, -1, -6. Well, let's see. This line, if I put it in slope-intercept form, I can read off its slope. So let's see. That's y equals, let's add 4 to both sides, 7 minus 5x. The slope of that line is -5. So the slope of our line must be the negative reciprocal of that. It must be positive 1/5. So I'll put this in point slope form. There's the point, there's the slope. It must be, its equation must be y minus a -6 is 1/5 times x minus a -1. There we go. Perfectly satisfactory answer.